And welcome to all of you. My name is Rachel Massey, and I'm the Senior Science and Policy Advisor with CHE, the Collaborative for Health and Environment. We are really pleased to be co-hosting this webinar with the Cancer and Environment Network of Southwest Pennsylvania. And I also want to thank Breast Cancer Prevention Partners for their collaboration. I'm really glad to be able to have this conversation today with my colleague and friend, Dr. David Kriebel. Looking over today's registration list, I see that we have a wide variety of participants here, including researchers, state and federal regulators, healthcare providers, tattoo artists, and others. I'm so glad that you're all able to join us, and I hope that each of you will find the information in this webinar to be useful. I'm just going to go over a few bits of housekeeping before we get started. First of all, please feel free to put a note in the chat introducing yourself. I see that many of you have already done that, which is great. And please type your questions in the Q&A box at any point, and we'll get to as many as we can after the presentation. If you'd like to download today's slides, you'll find them on the webinar page on our website at healthandenvironment.org, and we'll put that link in the chat now. If you'd like to activate closed captions, you can do that by clicking on the button on the bottom of your screen. And also, one important note, we scheduled this webinar to last for 45 minutes, but based on the amount of interest that we've had, we've decided to go ahead and extend to stay on for a full hour. So I hope that will work for many of you, and this webinar is being recorded. So if you do have to log off at the 45-minute mark, you can watch the rest afterwards. So now I'm very pleased to hand it over to my co-host, Andre Green, Network Coordinator for the Cancer and Environment Network of Southwest Pennsylvania. Andre?
Thank you so much, Rachel. Hi, everyone. I'm really excited to be here. And I'm very excited that we have the opportunity to partner with CHE on this event. As Rachel mentioned, my name is Andre Green, and I'm the Network Coordinator for the Cancer and Environment Network of Southwestern Pennsylvania, or just CENSPA for short. We are a network of over 50 organizations, and we strive to raise awareness and emphasize the intersections between environmental health, relevant scientific literature, harmful toxins, and cancer. And our advocacy exists to bridge gaps in cancer disparities exacerbated by environmental pollutants from medical and cancer-impacted populations. To learn more, you can find the link to our website in the chat. And as we move into today's discussion, we really want to acknowledge that tattoos are personal, spiritual, cultural, and they can represent the reclamation of bodily autonomy. We want to invite the audience to enter into this space with intrigue, with curiosity, and with interest. We honor the importance that tattoos have on individuals, and we deeply respect their meaning and their impact. We are in no way discouraging anyone from getting tattoos, nor are we passing judgment on those that already have tattoos, such as myself. This will be a space of safety, respect, and integrity. Now that we've set our intention, I'm very excited to introduce our presenter today, Dr. David Kriebel. David Kriebel is Professor Emeritus in the Department of Public Health at the University of Massachusetts Lowell and the Director of the Lowell Center for Sustainable Production, which collaborates with industries, government agencies, unions, and community organizations on the redesign of systems of production to make them healthier and more environmentally sound. He has published more than 130 peer-reviewed articles and co-authored 2 textbooks and has won numerous teaching awards. And in 2023, last year, he received the International Occupational Epidemiology Committee's Lifetime Achievement Award in recognition of his contributions to the field of occupational and environmental health. And without further ado, I'm very excited to pass the baton off to you, David.
Thank you very much, Andre and Rachel. It's just such an honor to me to be able to give this talk today. I have such respect for the work that the Collaborative for Health and Environment has done over many, many years, providing really high quality scientific information on environment and health. And I also want to really thank, really grateful for the sponsorship of the Cancer Environment Network of Southwest PA and the Breast Cancer Prevention Partners in California, 2 also outstanding organizations. I'm going to talk just for about 30 minutes today on tattoos and what we know, and actually mostly what we don't know about the health hazards from tattoos. But before I do that, I really want to echo something that Andre just said. You know, this is a really important topic, and yet it is a very different topic in a very important way, I think, than most of the other webinars that Che has given over the years. Mostly what Che has done and what I have done as an environmental epidemiologist is study chemicals, chemical exposures in the environment, and investigate their potential health risks. And there's a sort of an underlying theme that's so basic that we often don't even note it, which is if we're talking about pollution or food additives or pesticides or chemicals in the workplace, we, the exposed population, didn't give our consent. We didn't ask to have those exposures. That really, of course, really drives, doesn't it, the way we think about those risks and what to do about them. And of course, tattoos are really different in this way. People choose to get them. And more than choose, I think it really is important to note, as Andre was saying, that people choose to have tattoos for deeply personal reasons, spiritual, emotional. And so the place that I want to get to in about, I'm going to stop talking in about 30 minutes, and I'll tell you right now what I'm going to say at the end. If you want to just hang up and go have a coffee or take a nap, you can save yourself some time, because here's what I'm going to say at the end. I'm going to say, I think people should be able to choose to have a tattoo and not have to worry that maybe they're increasing their risk of some chronic disease down the road. But that's not the world that we're in right now, unfortunately. So with that context in mind, let me tell you what we know and a lot of what we don't know about exposure to chemicals in tattoos and what that might mean for our health. So tattooing, as you know, has been with us forever. It is a fundamentally human activity. My favorite example is this Iceman. This is a mummy, essentially, that was found frozen in the Alps in a glacier up above the Austria Italy border some years ago. He was 5,000 years old, frozen in the ice, and he had tattoos. The investigators who've looked at him think that at least some of those tattoos were actually medicinal. They appear to have been put over joints where he probably had pain. So he was being treated for his pain using tattoos. As you all know very well, in the last 20 years or so, tattooing has become much more common and much more colorful. And now about a third of adults in the United States have a tattoo. And actually, among young women, it's now more than half. People with tattoos will tell the folks who interview them, survey them, that they have various reasons why they get tattoos. But for example, nearly 2/3 say that they have gotten a tattoo to honor or remember someone or something that's important to them. About half say they want to make a statement about something that they believe. So these are very important personal reasons. Now, what is in tattoo inks? Well, they're very complicated mixtures. The most important part, of course, is the pigment that gives the color. Some of them are inorganic, that is to say, metals and other very simple molecules. The most important, probably, and which the Iceman probably had in his tattoo 5,000 years ago, is carbon black. But nowadays, those bright colors are mostly produced by synthetic organic molecules, pigments, that have been invented by chemists in the last few decades. They're synthetic. That's kind of an important point, that these are chemicals which human life and life on Earth doesn't know about. That is to say, the cells in our body haven't met these synthetic organic chemicals until just the last few generations. So there's been no time for life to evolve to deal with these toxic chemicals. And that is a potential concern of any synthetic organic pigment. In addition to pigments, there are many other chemicals, binders and solvents and carriers, preservatives, and so on. So they're very complicated mixtures. They do sometimes contain metals. Some of them are known to be toxic, like arsenic and chromium, cadmium, and nickel. Now, more and more tattoo inks contain nanoparticles, particles in the very, very small range, so that they can be delivered and I hopefully stay at the site of the tattoo. But these are new to us, to technology, to society. We don't really know much about how they're going to be handled by the human body. There are cancer-causing chemicals, carcinogens, in some tattoo inks. Here's a short list of chemicals which the International Agency for Research on Cancer, part of the World Health Organization, has determined are carcinogenic. But this is just a small sample, and these are chemicals which are known to be carcinogenic to human beings or to experimental animals. Frankly, I think the greater concern than those specific chemicals that are cancer causers are the thousands, literally, of chemicals in tattoo inks whose toxicity is almost entirely unknown to us. We just don't know because they haven't been tested. In the US, tattoo ink formulators are under no obligation to evaluate the safety of the chemicals that they put into their inks. And as a result, there are many compounds in tattoo inks whose toxicity is essentially unknown. And I think this is such an important point that I want to kind of try to drive it home with just one example, essentially chosen at random. I picked an ink and a pigment just to show you. I think this may help to stress this point about how little we know about these substances. So here's a tattoo ink. I went on the web, you can buy it. The manufacturer is not important to name because there's many of them, and I don't think this one's any different from all the others. But they offer an ink called Purple Rain, kind of liked the name, so I picked it. The website says all our tattoo inks are processed with the utmost attention and care in the USA in our clean room. Everything from mixing, pouring, bottling, labeling, packing, and shipping happens in our clean location. Our inks are cruelty-free, never tested on animals, vegan safe, and COVID safe. Well, the active ingredient, the pigment in Purple Rain, is a compound called pigment violet 23. And the manufacturer of Purple Rain provides on its website, as it is required by law to do, a safety data sheet that tells you what's known about the hazardousness of Purple Rain. So there's a list of what's in it up at the top there, and you can see pigment violet 23. But then there are some others. There's another pigment, white 6, and propylene glycol, ethyl alcohol. These are solvents and carriers, basically, and water. So it's pretty simple, actually. The manufacturer is required under law to tell you something about the hazardousness, or at least what's known about the hazardousness of this product. Says that there is that skin contact can cause moderate irritation. But then down here, it's quite revealing what's known, but maybe, again, I stress what's not known about other hazards. Aside from not knowing the difference between affect and effect, which is a minor grammatical flaw, you can see that the potential health effects of Purple Rain are listed as eyes, skin, and ingestion show no known significant effects. What about chronic health effects? Well, it says there is no known significant carcinogenic effect, no known significant mutagenic effect, no known significant teratogenic effect. Well, I have taken pigment 23, violet 23, and looked it up on a very useful database of the US Environmental Protection Agency. where you can find out what's known about the toxicity of just about any chemical. Here's the molecule of violet 23. I won't even try to pronounce its full name there. This is a pigment or dye that's used not only in tattoo ink, but in other products, as you see there. And here is a very useful summary in the EPA's database, CompTox, it's called, of what's known about the toxicology of violet 23. And you see all those little red X's. Those indicate that there is no information about any of these categories. So look over on the left, it says we have no cancer data. We have no genotoxicity data. We have no reproductive toxicity data, and so on. Over in the right-hand column, I'll just note there is no developmental toxicity data, and then no endocrine disruption relevant data available. There's a nice little green check mark down there at the bottom that indicates that we think there may be some eye irritation from this compound. So here's the point at which I stress a general principle in toxicology. The absence of evidence, that's what I've just shown you, is not the same thing as evidence of absence. Just because we don't know whether violet 23 causes cancer or is a reproductive toxin doesn't mean it is not one. And that is a very important point that is really one of the key themes of this whole discussion. You see, tattoo inks in the US are very poorly regulated. The Food and Drug Administration in the US has the responsibility for regulating tattoo inks, but it has very explicitly chosen not to do so. On their website, they have the statement that the FDA has not approved any inks for injection into your skin. The situation in Europe is somewhat better. The European Union, since 2007, has followed a comprehensive chemicals policy called REACH. And under that policy, just 2 years ago, in 2022, the European Union released a comprehensive set of rules on what could go and could not go in tattoo inks. And they restricted some 4,000 chemicals in tattoo inks, establishing maximum concentration limits for substances that could be used in inks and permanent makeup. And furthermore, they just said that automatically any chemical that is known to be carcinogenic, mutagenic, or a reproductive toxin, or a skin sensitizer, and so on, could not be allowed in ink. So they've just stated a blanket policy. I want to note here another little deviation from the tattoo story, because it's an important lesson more broadly, that this really demonstrates the very different approaches to chemical regulation in the European Union and the United States. In the EU, they follow what's called the precautionary principle. Here's a nice definition of it. When an activity raises threats of harm to human health or the environment, precautionary measures should be taken, even if some cause and effect relationships are not fully established scientifically. Some precaution is, and that's what the European Union is doing with its tattoo ink regulations. The situation in the US is quite different. We do not follow the precautionary principle, and it's what we do has been called the reactionary principle. And it's something like this. Anyone is free to introduce a new hazard into the environment, and governments must wait until very strong evidence of risk is accumulated before intervening. So that's the situation that we have here, and you can see it in the way that tattoo inks are being treated in the two different jurisdictions. Okay, so look, what evidence is there that tattooing causes chronic diseases? There isn't very much, very little direct evidence. So perhaps tattoo inks do not cause chronic diseases of any kind. It's possible, we don't know. So let me just quickly summarize what is known, a little bit about the fate and transport of inks in the body, the immune system's response to tattoo inks. We do know something about that, and that's potentially, I think, quite important. Some potential mechanisms that might be happening, linking tattoo inks to cancer and autoimmune diseases. And then a little bit of human evidence that actually does exist. So, of course, the whole idea with a tattoo is that the ink stays put, right? Stays right there in the skin, just under the surface where it is placed by the needle. But actually, much of the ink that's put in clears. Something like 80%, depends on how you measure it. But most of it is actually cleared away. Much of it in just the few weeks, days or weeks following the injection. And then there's another very slow clearance over years and decades afterwards, and you see it as the tattoo slowly fading. So what's going on, of course, is that there is clearance of the insoluble particles that have been deposited in the skin via the blood, and particularly via what's called the lymphatic system. And when a surgeon goes in and takes out lymph nodes around the site of a tattoo, she will find tattoo ink particles, highly colored particles in the lymph nodes, showing that the ink has been partially cleared. The way this is done is the way the body accomplishes this. There's a number of ways, but the one that I want to focus on is an active transport that's accomplished by cells in our immune system. The tattoo is a foreign body injected into the skin, and so it attracts immune response. That's a good thing. It's an attempt by our bodies to protect us from foreign invaders, of course, particularly bacteria, viruses, but also just a splinter in your finger, for example, a wound. And there's a very complicated immune response to foreign bodies, but one of the key components are cells called macrophages, specialized type called Langerhans cells, which are recruited to the site of the tattoo. They are called to the tattoo by the presence of these foreign compounds in an effort to remove them. There is a continual surveillance of our skin by these cells to try to protect us from outside invasion. These Langerhans cells phagocytize, that means they swallow particles of the tattoo ink and then present them to other immune cells for removal. This whole process is triggered by the presence of the foreign body, and cells are recruited continually to the site. They specialize into Langerhans cells. They attempt to remove particles. They do it partially, but not completely, because of course the tattoo stays, some of it. And this will go on indefinitely. So the immune system is continually stimulated by a tattoo. So the big question, of course, is this a problem? Well, to be honest, we don't know. We really don't know. It is possible that this continual stimulation of the cell-mediated immune response could lead to immune dysregulation of some kind. The hypothesis is that because the cells are continually being attracted and recruited, that increases the risk, the probability that there will be an error at some point in cell replication. And errors in cell replication are one of the hallmarks of cancers and also of autoimmune diseases. So this cell-mediated immune response to the tattoo, it's very complex. There's an awful lot of it we still don't really understand. But it seems possible that that errors in immune system replication could lead to a variety of chronic disease outcomes, possibly cancer, possibly autoimmune diseases. So specifically on cancer. There is a paper by our colleagues at the International Agency for Research on Cancer, Milena Forster and her colleagues there, who have hypothesized that particularly non-Hodgkin lymphomas, a particular type of blood cancer, might be expected to be at increased occurrence in people with tattoos because of this chronic immune stimulation. The other broad category of diseases that we are concerned may be triggered by tattoos are autoimmune diseases. These are diseases of the immune system which occur naturally or just spontaneously, as far as we know. But what happens is that the immune system makes a mistake and recognizes self, thinks that some part of our bodies is foreign, and mounts a failed and inappropriate immune response to self. That's the autoimmune part. These are diseases you've heard of probably, like rheumatoid arthritis, sarcoidosis, which can occur in the lungs and a variety of other parts of the body. Lupus is a disease primarily of the skin. These are autoimmune diseases. They're poorly understood, but it seems quite reasonable to think that they may arise from immune dysregulation, the kind of thing that perhaps is being triggered by some tattoo inks. So, do we have evidence that this happens? Well, we have very little from animals. There's almost no studies that have been done, so we don't know. We don't have that place to go look for evidence. There are in the literature what are called case reports, lots of them. So in other words, a physician observes, for example, a melanoma that has arisen in a patient at the site of a tattoo or near a tattoo, and the physician wonders, well, perhaps this is not just a coincidence, and so they publish a report. So you can find many case reports of these occurrences, co-occurrences, a tattoo and a disease for cancers, but also for a variety of blood cancers as well, pseudolymphomas and lymphoid hyperplasia. These are disease entities that are close to being lymphomas, but maybe not exactly. So there are lots of these examples in the literature, but the problem is this is really quite weak evidence because, as you can imagine, tattoos have become quite common. And so it will just happen by coincidence in some people that they'll have a tattoo and then they'll develop a skin cancer. And it doesn't mean that the two things are linked. So this is really not very much in terms of trying to find evidence that there is or is not a link. There is one epidemiologic study that we're aware of that actually has formally and accurately, appropriately investigated the association between tattoos and cancer. It was published fairly recently from a group in British Columbia, and they looked at non-Hodgkin's lymphoma and multiple myeloma in British Columbia, and they asked their study population about tattoos, so they were able to look to see whether there was a link, an association where tattooing increased the risk of either of these two diseases. And they found very limited evidence, just a little bit of an elevated association, but the study was really not very powerful as we talk about the power of a statistical study because it was small. This was a study in British Columbia in the early 2000s. The population are older, in their 60s. And as you can imagine, just remembering back to the early 2000s, not many folks in their 60s had tattoos. Only about 6% of this population was tattooed. So it's really quite limited evidence one way or the other. So I'm going to summarize now, finish up. And I thought the way to do that might be to just briefly point out what I think are some common misperceptions that I've heard in talking to folks about this question of our tattoos associated with cancer or other chronic diseases. And so one, I think, common misperception that people have is they think, well, if a chemical is allowed on the market, it must have been tested for safety. And this is false. And I hope I've shown you that. And sadly, it's not only the tattoo story, but for many, many chemicals in our environment. There's a related issue that is specific to the tattoo question that people sometimes ask. Tattoo artists in the United States, at least, and I think in most countries, are licensed, and that's a good thing. But this is mostly a law that arose to ensure sterile technique to reduce the risk of blood-borne diseases like hepatitis. Very important. It's good that we have that, but it really has nothing to do with the question of what's in the tattoo inks. Another common misperception that I have heard is, well, tattoos sit just in the very top layer of the skin and they stay there forever, don't they? So they must somehow be isolated from the rest of the body. They're out of reach of the bloodstream. And that's false. And I hope I've shown you that that is absolutely not the case, and that the immune system is forever aware that they are there. Another common misperception is, I think, that, well, look, people have been getting tattoos forever. I just showed you the Iceman 5,000 years ago in the Alps. So if they were dangerous, we would know it by now, right? Well, this is false. And this is a really important principle of epidemiology. Usually we talk about it in the very first day of the graduate course in epidemiology. The principle is, the problem really is that in order for a common exposure, tattooing, to cause a common disease, lymphomas, in order for that to be noticeable, we can see it to the public or even to physicians, the risk must be very large. And the best example of this is the story of smoking and lung cancer. It's actually hard to see. I use that word in quotes, but you know what I mean, to just notice that this link, even though we know very well that the link between smoking and lung cancer is very strong. It's a very large risk. And you know why, right? Everybody knows Uncle Al, who smoked 2 packs a day and died in his sleep at the age of 95. And that's right, because most lifelong smokers don't get lung cancer. And that does not disprove the reality of that strong link. So unfortunately, tattoos could be causing cancers, autoimmune diseases, and we would not be able to, quote unquote, see it. We need good epidemiologic studies in order to do that. So what is to be done? Look, as I said, I think people should be able to tattoo safely. I think that's absolutely appropriate, but we don't know enough to identify safe inks. The European Union regulations are a very good start, so I applaud that, but they are not sufficient. I think research is urgently needed. Epidemiology, clinical studies, and toxicology. There's no large research program underway to do this work, and I think it's very, very important. And in the US, at least, I think we should demand that the FDA start to regulate tattoo inks. And that is a very concrete request that is very reasonable. And the regulations are all there. The principle, they could do it, so they should be told that they should do it. Okay, that's the end of my little talk here. We're happy to take some questions. We have time for that. I'm going to stop sharing. I think Rachel and Andre are going to take over. How's that?
Great. Thank you so much, David. And I see there are lots of comments in the chat and the Q&A box expressing a lot of appreciation for this talk. So thank you very much. So I will start by choosing one of the many questions on the list, and then Andre and I are going to take turns choosing questions. So, all right, I'm going to start with this one. Are there any chemicals, if you have them in mind, that you think we should be most concerned about? Maybe a top three.
Mhm. Um, that's very difficult. I guess I would say it's not a top three, but I would say it seems difficult to argue with the idea that no known cancer-causing chemicals should be allowed in tattoo inks. And I showed you a slide with 8 or 10 of those or something. It seems pretty straightforward. There are toxic metals, for example. They should not be allowed in tattoo inks. But I do want to stress that that is simply removing those would not guarantee that they are safe, but it would be a place to start.
Great, thank you. Andre, over to you if you want to go ahead and do a few questions.
So a lot of wonderful questions. The one I want to raise is, does the toxicity decrease with time? Like a tattoo 10 years old is less worrisome than a new one?
That's a really good question. Of course, I have to unfortunately say we don't know because we don't have the studies. But I would add a little bit more than that, because if it's a big if, but if we are worried about the possibility that tattoos might cause, for example, lymphomas, it actually, then what we can do is we can go look at what we know about other environmental chemicals that cause lymphomas, because we know of some, hair dyes, for example. And what we know about those is that, in fact, the short term is not the problem. It's 10 or 20 years after. There's a latency to these cancers. So while we don't know for tattoos, I would say that actually we should worry about 10 or 20 or 30 years later. And that's why we're so concerned with the fact that now half of young women have a tattoo. What's going to happen in 20 or 30 years? Because that's when there may be perhaps some increased risk from these exposures if they are working as other known chemical carcinogens.
And as a follow-up question, conversely to the question that was just asked, when thinking about cumulative impact, would that also mean that someone is at greater risk of cancer or chronic illnesses with each additional tattoo that they get?
Yeah, unfortunately, we really don't know the answer to that question. And I guess the other thing I would just add there, I think it's fairly makes sense, but I just want to stress it. These are thousands of chemicals, and probably they're not all dangerous. Maybe none of them are, again, or maybe only 3 of them are. And if only we knew what those 3 were, we'd be fine. And so, you get one tattoo with one set of colors, and then you get another one with another set of colors. Maybe some of them are dangerous and some of them are not, right? So it's just not so easy to say. Presumably, the more you have, the more chance you have that you're being exposed to one that's dangerous, right? That just makes some sense. But again, unfortunately, I'm guessing here. I'm doing educated guessing. It's the best I can do.
Thank you. Now I'll toss it back to you, Rachel.
Okay. Let's see. So we have a question about, let's see, I'm just scrolling through because the list of questions keeps expanding. What do we know about natural non-synthetic inks that are being used by some tattoo artists?
Yeah, I don't know anything about them.
Okay.
But I do want to just a little asterisk. I want to stress that part of what is concerning about this question of tattoos is the route of exposure. We study all kinds of chemicals. We do animal studies of them. We feed them to rats and mice and things. We do human studies. We do in vitro studies. That means in cells. And we learn a lot about the toxicology, how different chemicals cause their toxicity. We know very little about what happens when you place a chemical under the skin and leave it there permanently. So it would be a mistake, I think, to say, well, it's a natural chemical, it occurs in nature, and therefore it must be safe, because it's a natural chemical, but it doesn't naturally sit under your skin with your macrophages finding it for the rest of your life. So maybe they're safer, I hope, but I don't know. I think it's a mistake. Route of exposure is really important in toxicology. There are lots of examples of chemicals which, if you eat them, they're not dangerous, but if you breathe them in and they get into your lungs, they're really dangerous, just by way of example. So the route of exposure, depositing under the skin, we know almost nothing about. And so I don't know that just because it's natural means that it will not carry risk.
Great. Thank you, David. So we have a few questions related to tattoo removal. So one person said, would the removal of a tattoo potentially decrease chemical risk? So thoughts on that?
Yeah, so this is a good point. I'm glad this was asked. Again, we don't know for sure because there's so much we don't know. But there is one thing to be concerned about here. One of the major ways that tattoos are removed is to use a laser, which places a very high energy beam just at that surface, just below the skin, and breaks up the chemical. I showed you that big molecule with all those rings of violet 23. The color has to do with that shape, that big hairy ring structure, as an organic chemist might call it. And what the laser does is it breaks the bonds and makes smaller chemicals. Unfortunately, we actually know that some of those smaller chemicals are more toxic than the big one. So actually, laser removal of a tattoo might actually increase the toxicity, not decrease it. We don't know, but there are some papers and some studies, experimental in pig skin or something, where they zap a chemical and then they test it and they find the creation of new toxic chemicals that weren't there in the original tattoo. So this is a concern.
Okay, great. Thank you, David. Andre, back to you.
So, David, I'm seeing a common theme of questions related to regulation. So I want to elevate this question. It says, the FDA regulatory process is very onerous. Is there another approach that would be easier to implement? Sorry, it just moved. Is there another approach that would be easier to implement to protect the safety of tattoo inks?
Well, that's a great question. I'm not sure I'm any better than any of you are at thinking of that question. Let's think about it. I don't know. To me, the problem is, so I guess what I'm thinking of, but it's just me. I'm not an expert on policy regulation here. What I'm thinking of is things like voluntary, seals. We only use such and such kind of compounds, and there are lots of examples of that, right? The organic sticker in your grocery store, and so on and so forth. Maybe, but the problem is that we have a fundamental lack of knowledge on which to base that. As I think I just said, I would be reluctant to put much stock in the idea that, for example, naturally occurring inks are safer. They might be, but I don't know. We need research. And so somebody's got to do that research, and that costs a lot of money. And so somebody needs to spend a fair amount of money to carefully do some good scientific research, and then use that research to inform a regulatory approach. And I agree with you that moving FDA, we get pretty discouraged when we think about how that's going to happen. But so maybe there's another way, but it should be based on science, shouldn't it? And the science is not there. And so that's really that's the sticking point, I think. We don't know what to do. It's not only that we don't have an FDA that's willing to regulate. It's that we don't know what to do.
And in relation to that last question, is the reactionary principle you mentioned the official position of the US regulatory agencies and laws passed by Congress, or your professional perspective on this paradigm?
Right, the latter. It's not, you won't find it written down anywhere in the congressional record. But it's just an observation on how things work here. Absolutely.
And back to you, Rachel.
Okay, let's see. Maybe staying with the policy theme, I will read two policy-related questions. One is, speaking of policies, what do you think will happen if evidence about risk of cancer or autoimmune disease of tattoos is found? Actually, I'll go ahead with that one before we go to another one.
Yeah, I think that's a really interesting question. And again, I'm not the right, I don't have any more expertise about that than any of you do. You tell me. But I do think I would just reframe it or focus on a particular piece of that, which I do think is very interesting, is what if we want, as I said, to get to a place where people are able to safely tattoo, what needs to happen? And how does that information need to get developed, the science? And and in the meantime, how does the awareness of the potential risk get communicated to the public? I think we can think of examples, you as well as I can, of situations of chemicals for which we know there are risks, and that information is not used, right? There's lots of examples. And so the translation from the evidence of the risk to changes in behavior is very interesting and very important. And it's not a scientific question, right? It's a political, it's a social question. How do people think about these risks? And what's the best way that we can tell them about them in a way that they can use that information? And I think that is worth some thought. How do we start talking about tattoo inks in a way that raises awareness, doesn't cause people to panic, but nor does it cause them to ignore the potential risk? I think it's a good question. I'd like to talk about it some more, but I think it's a question for psychologists and sociologists and anthropologists and so on, not only epidemiologists.
Great, thank you. Another regulation-related question is, what are the ways in which the European Union regulation on tattoo ink is insufficient? And David, I don't know if you'll have an answer to this, but I'll just say that people might want to look at the website of the Health and Environment Alliance, or HEAL, and Kristen might be able to put that link in the chat again, because this is something that they've been following.
Yeah, no,
but yeah,
good.
David, any thoughts?
Yeah, no, thank you. Yes, I think this is a very good point, and it, as I said, I'll just I think that what the European Union is doing is a good step, but again, the problem is we don't know what a safe tattoo ink would mean. We don't know what that is, because we cannot say with confidence that a tattoo ink which does not, in our experimental toxicology in animals and cells and so on, does not cause any hazards. It's not a carcinogen, it's not a mutagen, it's not a teratogen. That does not mean that it will not be a cause of chronic disease in humans, because it's being put under the skin where it's now going to sit for the rest of your life. And we don't know we don't know how to test for that except to do epidemiology. So I think it's a step in the right direction. It seems obvious, as I said, to just don't use those chemicals that we know are teratogenic, mutagenic, carcinogenic. And that's what the European Union is doing, and good for them. But it doesn't guarantee that there is no long-term health effects. I hope I've made that clear. It's just such an important point. It's a deep it's a deep ignorance that we have, because it's so different the way it's being delivered to us. It's not the same as eating it or inhaling it. We know a bit about those routes of exposure, so we can say if it doesn't cause cancer and so on and so forth in animals, and it's in your food, it's probably okay. But we don't know that about sticking it under your skin. I think that's such an important point. I hope that's clear.
Yeah, thank you. I'll read one more question and then back to you, Andre. So this is also a question that relates to the same point related to exposure route. So this attendee wrote, breast implants are associated with a type of lymphoma, but it's not specific to the texture or the material of the implant. I wonder if there's a study on the injection itself, any effects of the injection itself on the immune system besides the chemicals in the ink. So this is what you've just covered, but just wondering if you have any other comments related to that example.
No, it's a good point. I don't, but it's a good example of, yeah, exactly, something a little bit close in terms of the physical location and the fact that it's a foreign body there, and perhaps there's some keys, there's some links there in terms of understanding mechanism that could be useful also for tattoos. It's a good point. I don't know more about it. It's a good point.
Great. Thank you. Okay, Andre.
Another question in extension to the conversation about regulation. Is there any requirement for tattoo ink manufacturers to disclose the ingredients in their ink?
Yes, there is, and you can look at the in my slides, again the safety data sheet that I showed for Purple Rain is an example. Manufacturers, actually retailers of chemicals, are required by law to tell the public, tell consumers what's in the products, and with varying degrees of accuracy, as I showed you in that sheet. But there is a requirement to list ingredients. Yes, there is. There are certain limits about trade secrets. It gets a little complicated, but the principle is there, at least, that yes, you have to be able to know what's in a product that you buy. Yes.
And another theme that I'm seeing with a couple questions would be medical related tattoos, specifically construction tattoos after mastectomies. So often they are considered reconstructive. So should patients be more cautious? How should patients proceed moving forward?
Yeah, of course, it's a really good question. There are medical tattoos, very important. I guess I don't know, of course. There's no way to know, but all the same questions arise about what we don't know about potential mechanisms from the permanent nature of the tattoo. But I guess I'd just note that, in that situation, there's a pretty compelling health-related need, right? You're getting it because you're being prepared for a surgery or a treatment that's potentially life-saving. And so it seems to me it sort of changes the calculus a little bit. But I can't say more than that. We just don't know.
Thank you. And as we enter the top of the hour, I will give it back to Rachel.
Okay, great. Thank you. Well, there are lots of questions still there. So David, if you're willing, we can share the remaining list of questions with you afterwards and
Please, I
send
will
out
be
an
happy
email.
to. I'll be happy to answer as best I can. Any additional questions? Absolutely.
Great, great. Thank you.
Thank you.
Okay, so I will just go into the wrap up details now. Um, so as you know, this webinar has been recorded, and so the recording will be available on our website soon, and all of you will receive an email with a link to the video. We also would like to invite all of you to join us for upcoming webinars, and just to mention one that's coming up soon. On Wednesday, February 28th, the next Che Alaska webinar is titled The Realities of Chemical Recycling and the Plastic Pollution Crisis. We'll be hearing from Dr. Eric Carmona about a study of chemicals found in recycled plastics, and from Alaska Representative Andy Josephson about plastics pollution, recycling, and related legislation. And we'll put that link into the chat. So yeah, I guess we'll wrap up here. And so I just want to say thank you very much, David, for your leadership on this issue and for giving such a clear and very informative presentation. And Andre, it's been wonderful to partner with you on this. Thank you so much.
Yes,
Also
thank
want to
you.
say thank you to Kristen Schaefer, the Che director, who has been doing all the support behind the scenes. And thank you so much to all of you for your excellent questions and all the comments and information that you've put into the chat, and for everything that all of you are doing.
Yes.
So thanks so much.
Thanks to all of you.